Hello, this is a recording for Lesson 2-1, which means Chapter 2, Lesson 1. Chapter 2 is all about reasoning and proofs. We don't do the proofs anymore. The proofs are done for you. You just focus on the reasoning. So our objectives for Chapter 2, Lesson 1 are we're going to recognize and write conditional statements, and we're also going to write converses of conditional statements. So you basically have two ideas, conditional statements and converse statements. And as we go along, you'll see what those mean. Think about a conditional statement as anything in a game. When this situation happens, you go here. When this situation happens, you go there. It's all about levels of a game and having different things happen. That's where you see a lot of conditional statements is within computer programming. A couple of vocab words you need to know for this lesson. We're going to start out with a conditional statement. And basically a conditional statement is just a sentence that contains the word if and then. If something happens, then this happens. That is a conditional statement. Basically in geometry you can take any vocabulary word and put it in an if and then statement. Put it in a conditional statement. So you'll see throughout the year there'll be many lessons where you'll run into conditional statements all the time. The if part of a conditional statement is called a hypothesis. You see that in science experiments when you create a hypothesis before you start, and then at the end, once you apply all these properties and chemicals and whatnot into your lab, you draw a conclusion. That's the then part in math. So the hypothesis is the if part, the then part's the conclusion. A few examples I created of if and thens. The first one, if it is raining, then practice is canceled. Here's the if part, here's the then part. So if it is raining, then practice is canceled. Second one, if you are late to class, you are tardy. Sometimes in the if and then statement, the then is not even in the sentence, as long as you have a comma. After the comma is the then statement. So here's the if, you are late to class. Here's the then, you are tardy. The third statement is if a figure is a rectangle, then it has 4 right angles. The if part, a figure is a rectangle. The then part, it has 4 right angles. So again, many geometry definitions can be written in if and then statements. Another mathematical example would be if t minus 38 equals 3, then t equals 41. Here's the if part. Here's the then part. That's actually an algebra if and then statement. Those are all examples of what's called conditional statements. They have an if and they have a then. Okay, in our first example, we would like to write a conditional statement for the sentence, a right angle measures 90 degrees. The first thing that you want to do before you write a conditional statement is find the verb in the sentence. A right angle measures 90 degrees. The verb is measures. Everything in front of the verb is the if part. Everything after the verb is the then part. So to write a right angle measures 90 degrees in an if and then statement, which is conditional, I'm going to write this. If an angle is right, then it measures 90 degrees. That is grammatically correct, and it makes sense taking the sentence, a right angle measures 90 degrees, and making it conditional. When I write my sentences, I can't just say if right angle. That doesn't make sense. So I have to describe what I'm talking about. If an angle is right, then it measures 90 degrees. That is grammatically correct, and it makes sense. Second example, a square has 4 congruent sides. Well, yes, that's true. Now, I find the verb in my sentence, which is has. Everything before the verb is the if. Everything after the verb is the then. So when I write my if and then statement, I can't say if a square. Doesn't make sense. So I could do this a couple different ways. If an object is a square, then it has 4 congruent sides. I could also say if a polygon is a square, then it has 4 congruent sides. If a shape is a square, then it has 4 congruent sides. I can say all of those things. What I cannot say is if a square. Doesn't make sense. I also want to point out that the it is in the second half of the sentence. You can't have if it is a square. You don't know what you're referring to. The it has to go in the second part, not the first part. Okay, here's the third example. Complementary angles equal 90 degrees. True statement. It's the definition of complementary angles. 2 angles that equal 90 degrees. Now I want to write that in a conditional statement. I need an if and a then. So I find the verb. The verb is equal. So everything in front of the verb is the if. Everything after the verb is the then, but again, it still has to make sense. So if complementary angles, no. If they are complementary angles, no. I have to describe what I'm talking about. I'm talking about complementary angles. So grammatically, if two angles are complementary, then they equal 90 degrees. That complementary angles equal 90 isn't an if and then statement. If two angles are complementary, then they, notice the they is in the second part, then they equal 90. You can't say if complementary angles. I have to refer to if two angles are complementary, then they equal 90. Okay, now the second thought in this lesson is talking about the converse of a conditional statement. The converse of a conditional statement is switching the hypothesis and the conclusion, which is the if and then. So, when you have a conditional statement and I want to write the converse, the if becomes the then, and the then becomes the if. So you just switch the two. Again, it still has to be grammatically correct and it still has to make sense mathematically. So we're still writing sentences, however, we're going to switch the if and then. Now, in this first example, if two lines intersect to form right angles, then they are perpendicular. I want to write the converse of that sentence. The sentence is already in an if and then form. Here's the if, here's the then. So it's already conditional. Once it's conditional, I want to switch the if and the then. So the if part becomes the then part becomes the if. So I say that if two lines are perpendicular, two lines are perpendicular, then they intersect to form right angles. That is the converse of that conditional statement. Now, notice how I described the lines in the first part. I have to tell you if two lines are perpendicular. Don't just say if they are perpendicular. You don't know what they is referring to. Notice how the they is in the second half. The they or it can only be in the second half. It cannot be in the first half. If two lines, because you had two, if two lines are perpendicular, then they intersect to form right angles. That's writing the converse of that conditional statement. Now in math, a lot of times when you have a definition, you can write the conditional, you can write the converse, and sometimes when you write the converse, it's not necessarily true. Now in this statement it is. If I look at the conditional up here, if two lines intersect to form right angles, then they are perpendicular. Yes, that's the definition of perpendicular. If I look at the converse, if two lines are perpendicular, then they intersect to form right angles. Yes, that's true also. So both of these are true. Sometimes when you write the converse, that statement is not necessarily true. Okay, I want to write a converse of this sentence. A straight angle measures 180 degrees. Okay, so in my eyes, I first have to write the conditional, then I have to write the converse. So for me, I'm going to write the conditional first of that statement, and then I'm going to write the converse. To write the conditional, I have to find the verb. Measures is the verb. So this, a straight angle, is the if part. Measures 180 degrees is the then part. So conditional, if an angle is straight, then it measures 180 degrees. That's the conditional. A straight angle measures 180 degrees. That's the sentence we start with. The conditional. If an angle is straight, then it, notice the it in the second part, it measures 180 degrees. Okay, here's the converse of that. Here's the converse of that. If an angle measures 180 degrees, then it is a straight angle. So the converse of that is if an angle measures 180 degrees, then it is a straight angle. So now the second part is the first part. First part is the second part. But the if and then still goes first. If, then then. The last concept in this lesson is a counterexample. In math, many times we are given a statement and we want to find an example that makes that statement false. The example that we find is called a counterexample. So take, for instance, if the name of the state contains the word new, then the state borders a body of water. So we need to think about all the states that begin with the word new and visualize them on a map, and do they all border a body of water? If we can find a state that doesn't, that state is considered a counterexample to the statement. If the name of a state contains the word new, then that state borders a body of water. So the four states are New Jersey, New Hampshire, New York, New Mexico. So we have to visualize these four states. They all begin with the word new, and do they all border a body of water? Here's New York, and here's water here. Here's New Hampshire, and here's water here and here. Here's New Jersey, and there's water to the right of New Jersey. But if I look at New Mexico, I don't see any water that borders that state. So my counterexample of that statement, if a state begins with the word new, then it borders a body of water. My counterexample, New Mexico, that does not border a body of water. That is a counterexample. Here's another statement. You can connect any 3 points to form a triangle. Well, here's 3 points. Can I form a triangle? You bet. What about this one? I have 3 points, they're collinear. Can I form a triangle with those 3 points? No. So this, folks, is my counterexample. So in this case, this is a picture, not a statement. It's an actual picture. This proves that wrong. Okay, here's another one. Hits more at home. If you attend Shaler Area High School, then you live in Etna. Okay, well, that's a statement. It's if and then. I want to prove that wrong. Well, what about the people that live in Millville? Don't they attend Shaler High School? That's a counterexample. What about Glenshaw people? What about Shaler Township? What about Reserve people? What about Birchfield? Etc., etc. All of these are counterexamples to this statement right here. That's what a counterexample is. Counterexample proves a conditional statement false. Sometimes it's a picture, most of the time it's just a word or a phrase. So to sum up, conditional and converse. When you have a conditional, you have an if and then. If an angle is a straight angle, then it measures 180 degrees. That's the definition of a straight angle. Now, how we write it in math is we write this. P implies Q. That's a conditional statement. You read it, if P, then Q. That's a conditional statement. The converse is just the opposite. You take the then and it becomes the if. You take the if and it becomes the then. If a measure of an angle is 100 degrees, then it's a straight angle. Mathematically, we read it like this. Q implies P, or if Q, then P. The third concept, conditional, converse, and then the third concept would be counterexample. That is the lesson. Chapter 2, Section 1. Okay, so to end the lesson, let me leave you with this question. How do you prove a conditional statement is false? Well, if you can find what's called counterexample to the statement, then I've proven the conditional statement is false.